Today we will learn about concentration. Our question of the day is, what is the difference between a relative and absolute measurement? You should have three solutions in front of you. I want you to color in the solutions based on what you see. Use the terms dilute and concentrated to describe each solution. If you are not in class, you can color the solution in like so. Notice how the lightly colored solution is dilute and the dark colored solution is concentrated. A color in between will be in between the most dilute and concentrated. We use the terms dilute and concentrated as qualitative relative terms. If we want to quantitatively determine how much solid is in your liquid or how much solute is dissolved in the solvent, you will need to use one of four different ways. First is percent by mass. This is how much solute is in the solvent with respect to the mass. It is expressed as a percent. To find percent by mass, you will take the mass of the solute, divide by the mass of the solution, and multiply by 100. Second is percent by volume. How much solute is in the solvent with respect to the volume. Usually it is a liquid dissolved in a liquid and is expressed as a percent. Mathematically, this is the volume of the solute divided by the volume of the solution times 100. Next is parts per million. How much solute is in the solvent with respect to mass and is expressed out of 1 million. So you take the mass of the solute and divide by the mass of the solution, then multiply by 1 million. Our units will be parts per million, or ppm. Lastly is molarity, or how many moles of solute is in liters of solvent. For example, 3 moles per liter. Mathematically, you take the moles of solute and divide by the liters of solution. The units will be molar, or capital M. For those of you who are interested, there is another unit called molality. We will not be learning about that unit this year. Now pause the video and try the show what you know questions. When you are done, you may resume the video and check your answers. What is the concentration of a solution that contains 50 milliliters of alcohol dissolved in 500 milliliters of water as a percent? Well, if we are talking about percent by volume, then you want the percent of the solute, which in this case is alcohol, so 50 milliliters, over the volume of the solution, which is the solute plus the solvent. So 50 milliliters plus 500 milliliters. And since we're looking for a percent, we will have to multiply whatever we get by 100. So 50 divided by 550 times 100 is 9.1%. Next, we want to know how many grams of solute are in a 22.8 gram solution that is 27% by mass sugar. Here, the percent by mass is 27%. That is equal to the part that is sugar, the solute, over the whole solution, so 228.0 grams times 100. So we will now solve for x. X is equal to 27% divided by 100 and times 228.0 grams, which gives us a total of 61.56 grams of solute. For number 3, consider what is the concentration in parts per million of a solution that is 2 grams of lead per 100 kilograms of solution. To find parts per million, we're going to take the grams of solute, 2 grams, divide it by the grams of solution. In this case, we have 100 kilograms, or 100 times 1,000 grams, because there's 1,000 grams in a kilogram, and then times 1 million to make it parts per million. Now, let's type this in the calculator. and we will get a total concentration of 20 parts per million. Next is number 4. How many grams of solute are in 500 kilogram solution if the concentration is 1.3 parts per million? So once again, we're going to find grams of solute over grams of solution, which in this case is 500 kilograms times 1,000 grams per kilogram. And then we're going to multiply this by 1 million, and that will give us a resulting concentration of 1.3 ppm. Now we need to solve for x. So we're going to take x is equal to 1.3 divided by 1 million times 500,000. Type this in your calculator and you will get a total of 0.65 grams of solute. Next, we want to know what is the molarity of a solution that contains 2.3 moles of solute per 3.7 liters of solution. Molarity is given as moles, 2.3 moles, per liter of solution, so 3.7 liters. Now, if you type this in the calculator, you will find that this is a 0.62 molar solution. Next, we want to know how many moles of solute are in a 500 milliliter sample of a 15.0 molar solution. Remember, molarity is always given in moles per liter. So that means our 15.0 molar solution is made up of some unknown number of moles divided by liters. In this case, our liters is 0.5 because 500 milliliters is 0.5 liters. If we solve for x, we will get x is equal to 15 times 0.5, which is 7.5 moles. Next, what is the molarity of a solution that contains 34.9 grams of NaCl per 500 milliliters of solution? To get molarity, we need moles per liter. So moles on top, liter on bottom. Right now, we've got grams, so 34.9 grams per milliliter, 500 milliliter. So let's convert our milliliters to liters. We know that 1,000 milliliters is 1 liter. Next, we need to convert grams of NaCl to moles of NaCl. To do that, we will need to use the molar mass. Sodium has a molar mass of 22.99 grams per mole. Chlorine has a molar mass of 35.45 grams per mole, which means the total molar mass of NaCl is going to be 58.44 grams per mole. Looking at our dimensional analysis chart, we now have 34.9 times 1,000 divided by 500 divided by 58.44, or 1.19 moles per liter. So this is a 1.19 molar solution. Lastly, we want to know how many grams of potassium nitrate are in 250 milliliters of a 3.0 molar solution. Starting with 250 milliliters, we know that there are 1,000 milliliters in 1 liter. We also know, because 3 molar means 3 moles per liter, that 1 liter is 3 moles. Then we're going to say that 1 mole of KNO3 is how many grams? Potassium has a molar mass of 39.10 grams. Nitrogen has a molar mass of 14.01 grams. And oxygen has a molar mass of 16.00 grams. Since there are 3 oxygens, that means we're going to do 16 times 3 plus 14.01 plus 39.10, which is 101.11. Now, 250 milliliters times 1 liter times 3 moles times 101.11 grams divided by 1,000 milliliters divided by 1 liter divided by 1 mole is 75.8 grams of KNO3.